Polly has now opened a shop. Over the first few weeks, she has kept records of the number of customers shopping per hour. So that's quite a key idea, per hour. The results are given in the probability table below. 1 to 3 is 0.09, etc. Calculate the probability that exactly 8 customers shop at Polly's in each of 2 one-hour periods. State the name of the distribution you use and any assumptions you make. Explain what you are calculating at each stage. Well, it's the number of customers shopping per hour. So because it's a rate of customers per hour, we're going to assume that's going to be our lambda. In other words, we're going to have a Poisson distribution. We can also comment about the fact that the arrival of customers is random, that they're independent of each other. In other words, if we know one person's arrived at the shop, it has no effect on whether the next person arrives or not. We're also going to assume that 2 people can't arrive simultaneously. It is also the distribution of discrete data because you count customers. So, first of all, then, to work out the probability that exactly 8 customers shop at Polly's in each of 2 one-hour periods, we need the probability that x is equal to 8, and that's going to happen twice, so the probability is going to be multiplied by itself. And it's each of 2 one-hour periods, so we want to find the average per hour. Now, if we look at it, we have a problem here because we don't know exactly the probability of exactly 1 customer or 2 customers. We've got 1 to 3 inclusive is this. And if you notice, we haven't got here the probability of 0 customers. So what we need to first of all work out is the probability that we have no customers. And that's just going to be 1 minus all of these probabilities. 0.09169 plus 0.38711 plus 0.37027 plus 0.14982, and we'll say that comes to 0.9988, and if we do 1 minus our answer, we'll end up with 1.11 times 10 to the power of negative 3. Just going to get that light on it so you can see a bit easier. Oh, that's a bit lighter. So that's 0.00111. Now, we now know the probability that x is equal to 0, which means we can now work out lambda. First of all, we need to go to our formula sheets, to the Poisson distribution, and we need to look at this formula here. So the probability that x is equal to 0 is lambda to the power of x, and x is 0, e to the power of negative lambda divided by x to the power of 0, or 0 to the power of 0. X is equal to 0, that probability is 0.00111. Anything to the power of 0 is just 1, so that's just a 1. And 0 to the power, 0 factorial is also equal to 1. So those two cancel each other off, and that happens every single time you do these types of questions, and it's e to the power of negative lambda. Now we need to cancel off the e. The opposite of doing e to the power of x is the ln of x. If you look on your calculator, you can see that we've got ln of x here, and we've also got, if that's the ln of x, we've got e to the power of x, which is just a button ahead of it. So these are opposites. So we take the ln of both sides of the equation, the ln of the left-hand side, and do the same to the right-hand side. So now that the ln of 0.00111 is the same as negative lambda. Now we can work out the ln of 0.00111, and that gives us negative 6.803. That's negative lambda, so lambda will be 6.803. Now we found the rate per hour, we can do the calculation. So we now need to find the probability that x is equal to 8. So the probability that x is equal to 8, we're going to use our calculator. Go into Poisson distribution, it's PPD. X is equal to 8. The mean we just worked out is 6.803, and the probability is 0.126. Now we want to have 2 of them arriving. We're going to say 0.126 times itself, or squared. 0.126 squared is 0.0158, or 0.016.